Hello, I'm Ehsan. In this video, I want to explain UART as a peripheral and how it works in STM. So let's see the summary of UART in there. You can see I write some point in here to explain about UART. Introducing UART or USART. It's a little bit different between UART and USART, but we work on UART. UART is universal asynchronous receive and transmit. This is the means of UART, and then is why we use UART. When we want to connect two devices and receive and transmit data between of them in form of serial, we should use UART. You can see this figure in here. For example, device 1 is micro and device 2 is other module. We want to receive and transmit data between both of them, and we should use in UART. Then we have 4 points in UART. We must know about that: baud rate, data bits, parity, and stop bit. Baud rate, it means transfer data in which speed. Familiar baud rate are this and this and this, and I use this baud rate uh, 1050 2000. After that, data bits, it is everything we transfer between two devices. It can be between 5 to 9 bits. After that, parity, it can be odd or even, and it depends on data. In most project, parity is none. And the stop bits, it is most time 1 to end of the data. It means transfer data is finished. You can see that. After that, figure can help us understand principle of UART. We have this pulse as input. 3.3 volt is idle. After that, this level change to 0. You can see this level change to 0, and start bit, we have a start bit in situation. After that, this part is data bit until there, and we have parity. It depends on what end of data bits. It can be 0 or 1. In most project is known is really better than. After that, we have stop it in here and go back to idle. You can see that this part is begin. We have a idle and change the level. You can see that. After that, start transfer. We have data bits in here. You can see 1120 0. At the end of 0 is referred to parity, and we have idle in here. Go back, idle in here. And the next part is communication UART. For example, we have device 1 and device 2. RX is connected to TX, and TX is connected to RX device 1. At the end of that, ground is connected together. Okay, this is the summary of UART, and go and make project with UART. Okay, I use STM Hall. Yeah, this part is really important to know about that. In this video, I use Hall underline UART underline transmit, and we have receive, transmit IT, receive IT, and so on. You can see. But in this video, I work with Hall underline UART underline transmit. Okay, go to make project. I make it before and I want to explain what happening there. I use UART2 and this is the CubeMX project. I show what's happening in CubeMX. After that, go through the code code and I explain it. Okay, this is my micro. Uh, as always, we go to the system, change this part. After that, go to connectivity and go to UART2. You can see this table. In first of all, you can you must change asynchronous mode in UART. After that, go there, go to parameter setting and change the baud rate. Mm, I use this baud rate and word length 8-bit from my code and parity is known as I said and stop bit is 1. Just that. User contact nothing is here, NVIC nothing, DMA nothing, and GPIO setting you can see we have nothing. It's only change this line is related to baud rate, word length, 8-bit, and parity is known and stop bit is 1. And generate code. After that, go to the Kale. Okay, STM CubeMX make this file and line by line I explain. I add in this include in my project. After that, I define this variable int I0 and an x. Line 43 STM CubeMX make it. It's not important. I write it. 15, 51, and 52 STM CubeMX make it. Okay, this word 54 until 66. Add this code because I want to use printf format. It's not transmit hall. Uh, uh, Copy this code line by line. In this line you can see. Let me go up. This code it help us to use printf like we want or we use C language and line by line you can add. After that, okay, this line is for STM CubeMX 91, 98 for STM CubeMX, 105 for STM, 106 as I say. This is my code. I write a delay. You can see with all. After that, use printf to this format. Write and use after that is delay and I plus plus. I define variable I because I want to count my string when I send to or transmit my string to computer. I want to count it and everything is here and nothing is changed. You can see my baud rate in here. STM CubeMX make it not important, don't worry about it. Everything is correct. Okay, uh, compile it. Zero error, zero warning. Before I program it, I want to explain. I use this chip to serial ports to connect my computer and it's CP2012 module, USB to TTL. Okay, and program this code on my board. Yes, I program my code, and yeah, this is a module. As I said, I use it, and you can see three pin in here, uh, PL3, PL2, and the black wire is connected to ground, connected to this, and after that, it connected to USB port on my laptop. Okay, let me connect it to. This is my board. It's not complicated. Okay, uh, and I use a Hercules terminal to uh, show my string. You can use PLC test, Hercules, real time, or the other program you want. Okay, I set the COM port. After that, set baud rate, data bit size, parity is none, and shake hands off. And let me show where is the COM port. Go to manage, go to device manager. After that, you can see that in here ports, you can see CP210 USB as defined as COM port 4. Okay, and I want to open it, and you can see write my string in Hercules setup, and this is my program. I write in there, where is it? Okay, I write self dash study electronic engineer. This is my YouTube channel, and the variable, the count it, you can see that in Hercules 0 self-study electronic engineer, 1 self-study electronic engineer, and so on. Okay, this is the first code I write for transmit. Then go to the next. Okay, second is transmit. This is the second project I write it. Go to STM and show which option I ticked in here. Okay, you can see PL3 and PL2 defined as UART, RX and TX. Go to system and change it, as I always say. Go to connectivity, take the UART and change this mode to asynchronous. After that, go to parameter setting, set this baud rate. Word length is 8 bit, parity is none, and stop bit is 1. And the other option is nothing. You can see I do nothing in here, just change parameter setting and generate code. And after that, go to your Kale and show what happened. Okay, I add this include my project. After that, I define two variable in here, len and buffer. Before I explain my code, I want to show uh, what's the transmit of UART. Go to hall underline UART transmit, and you can see this is the function. HUART is this pointer. We have 1, two, three, and four parameters in here. At first, in hall transmit, I want to explain this part. At first is which UART I use. After that, we use, where is it? After that, we use p data, pointer to data buffer. Always in here, I use buffer. After that, we need the size of that. Where is the, uh, the len is parameter or variable. It can show the size of my string, and the last one is about timeouts. Okay, two variables are defined. After that, go to the while. I use sprintf in my code in second code. It means I define the buffer. After that, I save this character to buffer, and the next I this is the C. It's related to C language, and we have strlen. It means we want to know about size of character and read the buffer and save the size of the character in len or len. After that, I use hall underline UART underline transmit. First is about which UART I use. Next is about buffer, is p data, and the next one is about side, and the last one is about timeout. Okay, I compile this code, zero error and zero warning. After that, compile, and you can see right, welcome, welcome, welcome. I write in here, welcome. Okay, the last one in here. And the last project I want to show about transmit in here. I write it as a tutorial in YouTube. Go to STM Wait a second until STM Yeah, we have it. Go to connectivity, take UART, change this mode again, change the parameter, baud rate, word length, parity is now, non-stop it is 1, user contact is nothing, NVIC is nothing. Go to DMA. Yeah, this part is different in here. Go to DMA and click add. When we click add, you can add this item in here and click in it and change the mode normal to circular. After that, everything is okay. This is different. In last two codes, we don't have DMA setting, but in last code, we have DMA setting to use transmit. Okay, click add and choose this item. After that, change the mode. You can see that change the mode to circular, and the in here is nothing. Everything is changed. Click the generate, and we have this code. Okay, uh, I use main.h. This too is generated by STM Yeah, I define my text data in here in initialize. Yeah, this is really important. After that, I use transmit, which UART is 2, my TX data, and then is about size. This code, we don't have len. I write this size of my TX data, and the timeout is 10. After that, we have delay in while, and do nothing in here, and you can see my baud rate or everything you want. Compile, zero error and zero warming. After that, uh, okay, compile it, open the gate, and you can see I write it in global. Hello, I'm Ehsan. Write this. This is the last code I write in transmit UART. This is for transmit. To next video, I will show you uh, to which to what is the receive in UART and write my code. Thanks for watching me. Please subscribe me.